So let's go to the next speaker, is Roland Strausz.
Okay, so this is joint work with Daniel Kramer, who's in Bonn. So optimal sales contract with withdrawal rights. So some of you may have seen some version of this paper before, even under a different title, Benefits of Sequential Screening. Yeah. So this is the same paper more or less, but we put it, well, we hope at least, in a nicer perspective or a nicer application. Yeah. So we talk about contract withdrawal rights now. Yeah. So what are contract withdrawal rights? Well, there's a big you have to make a big distinction between so-called voluntary rights or mandatory rights. So when people write a contract, yeah, they're all, of course, yeah, free to write into the contract a right of withdrawal. Yeah, so that I would call a voluntary right of withdrawal. Yeah, and that can then be part of the optimal contract, and this is kind of an endogenous withdrawal right. Yeah, so it's non-restrictive. So what we were talking about here is something which is a limitation on contract, a restriction on contracting, so-called mandatory withdrawal rights. Yeah? And we think they are actually not studied very much, but still there are a lot of contexts where there is this withdrawal right put on as a restriction on the contracting space of contracting partners. So just a few examples. So labor contracts. Yeah, we know that people. We have non-slavery conditions. You cannot keep the worker on any condition. Yeah, the worker can always leave at will. Yeah, you have limited bonding. You cannot ask the worker to give up a bond before they leave. Yeah, so the worker can always withdraw. Yeah, has the right of withdrawal if the employment relationship turned out badly. Yeah, so in academia, if you look for a different job and you already have tenure, yeah, you often even take an absence of leave, yeah, in order to find out whether the new job is nice. Yeah, you can always come back. Yeah, you can always withdraw from the new tryout of the job. Yeah. Another example are procurement contracts. Yeah, so in procurement contracts, when the contractor is a firm, yeah, protected by limited liability, there's always the risk that this firm may go bankrupt, the contractor may go bankrupt, and from the procurer, this looks like an exit option of the contractor, a sort of withdrawal right from the contractor. Yeah. So what we'll be focusing on, or what I'm be focusing on today, is withdrawal rights in the context of consumer contracts, but I think the other two examples would fit our story as well. Yeah. So in consumer contracts, our application is EU, the European Union, has a regulation on so-called distance sale contracts, which is basically any contract you buy when you buy goods over the internet, that you're allowed to return these goods without any questions asked 14 days after receiving the good. Yeah? And it's more than a return right. Yeah? You actually withdraw from the contract. Yeah? You can cancel the contract without any problems for 14 days, up to 14 days after receiving the contract. So our question is, what of this paper is, how do these mandatory withdrawal rights affect optimal contracts? And I'll focus on the consumer contract case. Yeah, so our main application is the sale contracts of the EU regulation. So here are two sections, direct quotes from the regulation to give you a little bit an idea what the idea of the regulators is behind this this withdrawal right. Yeah, and I'll just quote a little bit. So since in the case of distance sales, so this is internet sales, for example, the consumer is not able to see the good before concluding the contract, he should have a right of withdrawal. Yeah? And the quote of section 47 says something similar. Yeah, especially the last part is interesting. For example, the consumer should only try on a garment and should not be allowed to wear it. Yeah, so that's the idea of why to give a withdrawal right. You buy a jeans, or shoes over the internet, and you cannot try it on like in a shop. Yeah, and that's therefore you should get a right of withdrawal. Yeah? So this is not a voluntary right. Yeah? This is written into the regulation. This has to be part of the contract. Yeah? And so if you read these quotes, what the regulators more or less have in mind is that if you compare buying goods in a traditional shop to buying goods over the internet, then the informational position of the consumer is worse over the internet, and there's some protection idea behind this regulation to restore the consumer's informational position. So one question you could ask is, well, does this work? Okay. What is the idea of this withdrawal right? How does it connect? How do we model? How will we model it? So it's about information. So we have a consumer who has some willingness to pay. Some idea about the willingness to pay. I need a new jeans. But I don't know whether I need one for Levi or another kind of jeans. And only when I see the product and try on my jeans, I actually obtain additional information, and I better know my willingness to pay. So how does it work in a traditional shop? You go to a traditional shop, you try on the jeans, and then you conclude the contract, and you buy the product. So in a traditional shop, the right model is simply the monopolistic screening model in a monopolistic context of Baron and Meyerson. Now the idea here is, in a distance sales situation over the internet, you don't know yet this information, whether the shoes will fit or the jeans will fit. So the consumer learns additional information after contracting. So a distance sales contract, taking into account this informational aspect, is more in line with a sequential screening model from Courtier and Lee, where you have where the consumer or the agent has some ex ante private information, but get more private information later on in the relationship. So then, if you want to narrow down what we're doing, we are asking the question: how do withdrawal rights affect sequential screening? Okay, so what we're going to do is something reasonably simple. We're going to take the Courtier and Lee framework, and we will put in withdrawal rights there, and we'll see what comes out of it. Okay. So what is the model? So we have a principal and an agent. The principal wants to sell something, the jeans, the shoes, to the agent, and theta will be the agent's willingness to pay. It's somewhere between 0 and 1. And the cost of the production is C. That's the cost to the principal of producing the good. Then the terms of trade are very simple. There's a probability of the sale, that's the X, and a transfer from the agent to the principal, some amount in R. Nicely simple quasi-linear framework. The principal's utility is simply what he gets as a transfer minus the cost, times the probability that he will actually supply the good, and the agent's utility is simply his willingness to pay times X minus what he has to pay. So very, very standard. So what is now the information structure underlying all this? So the cost C will be common knowledge. Everything is known about that. The principal, agent know everything. So what happens in period 0 before the contract is written? The agent does not learn theta. No, he learns that his true valuation, the theta, will be drawn from this distribution GI. And this is common knowledge. That this I occurs with probability PI. So I, what I am as an agent is this ex ante private information is already a little bit that I know something more than the principal about how much I will need my jeans. Okay. So then in period 1, then in period 1 the principal offers his contract specifying some menu maybe from the combinations of XT. And then after concluding the contract over the internet, I get my jeans sent home. I open the package, I try them on, and then I really learn whether they fit. I learn my real theta. So theta is the ex post type. My real valuation. And this is private information of the agent. The principal does not see whether the jeans will fit when I try them on at home. And now the really new thing in comparison to Courtier and Lee, because this is just like in Courtier and Lee, is now this in bold red. The agent can simply withdraw after learning his ex post type and get his outside option of 0. So he can send the good back, and then the contract is cancelled, and he gets back all his refunds and everything he paid. Okay, and if the agent says, no, I like the genes, I'll keep it, then the contract remains valid. Okay? So, what are the assumptions we have to put on this structure here? So, some technical ones. Yeah, that's GI differentiable, that's how it's, and the density exists. It has a non-shifting support, so theta lies always between 0 and 1. Yeah. Then we have the hazard rate, yeah, which is common in mechanism design. Yeah, contract theory is monotone, is increasing. Yeah, and a new thing we'll need is what we call so-called cross hazard rates. So you see that here there's a GI, and here is the density is a small j. Yeah, okay. So the cross hazard rates, yeah, in our framework we'll assume will also be increasing. Yeah, okay. Well, do these distributions exist? Yeah, they exist. Yeah, so if, for instance, if the GI is convex for all I, that's satisfied. Yeah. And yeah, so we don't need any additional assumptions. I'll come to that in comparison to Courtier and Lee. They don't need this, but they need something additional. I'll come to that. Okay. So, what are the contracts? Yeah, well, what the contracts do we have to consider if we want to find the optimal contract now for the principle? Well, we can appeal again to a revelation principle, yeah, in the dynamic framework here. So, an optimal contract is direct and incentive compatible, meaning that the agent, yeah, has to report the information immediately after receiving it. Yeah, so at the contracting stage he has to report the I, yeah, and then he reports the theta as soon as he learns the theta. Okay, so what is a direct contract? A direct contract is a menu of XTs, yeah, where there is a reporting about the I, the type, and a reporting later about the theta. Yeah, so that's the general contract we have to consider, given the dynamic revelation principle. Yeah, in the period R1, the agent has to report his ex ante type, and in period 2, his theta type. Okay. So what about incentive compatibility? Yeah, part of the revelation principle. So the period 2, they are standard. Yeah, so I have to make sure that given that, that I had already reported some type J, yeah, I am going to report the theta truthfully. Yeah, okay. So what are the incentive compatibility constraints for period 1 about my I? Yeah. So I have to tell truthfully my I. Yeah. Given that we have a non-shifting support, yeah, I will also have truth-telling of the equilibrium path. So my incentive constraint is quite simple. Yeah, I just have to make sure that, yeah, I can assume that I will report my theta later honestly. Yeah, that's not without loss of generality. It comes from this one. Yeah, so the incentive constraint of the first period is very straightforward. Yeah, it holds on and off the equilibrium path because of period 2. Okay. So individual rationality, when do I participate? Well, of course, this is a standard individual rationality constraint in the Courtier and Lee framework. I just have to make sure that when I'm buying the product, when I'm ordering over the internet, yeah, then on average, yeah, I get at least 0. Yeah? Now, what is now the new thing? The new thing that we add is, no, we don't only need on average 0, we actually need for every state, yeah, that the agent gets, yeah, likes the genes, yeah, is willing to keep the genes, yeah, doesn't send it back. Okay? So the whole new thing is just adding this simple little constraint. That's all. Okay? So I didn't say anything silly yet, I think, but yeah. So, the principal's problem, yeah, with withdrawal rights is then simply we're going to maximize the expected payoff of the principal, so the transfers, the expected transfers he gets, minus the cost, yeah, under these incentive constraints and these individual rationality constraints. Yeah? If we do the standard approach, if we forget about the withdrawal rights, yeah, I have almost the same problem, yeah, I just can forget about the IRXP. Yeah, and this is what Courtier and Lee do, yeah, and this is this sequential, what we call sequential screening. Okay, so here is what Courtier and Lee get. Yeah, if you take this additional assumption that yeah, these GIs are ordered, yeah, stochastically ordered in the correct way, yeah, then we have that indeed, yeah, under the optimal contract, the principal screens sequentially, yeah, saying that it offers menus. Yeah, where he offers different combinations of of probabilities of sale and transfers, depending on the ex ante private information. Yeah, so the ex ante private information in this framework is really used. Yeah, that's really screening by the eye and screening about theta. Yeah? Okay. So what is our result? Our result that as soon as you, or if you put in these ex post individual rationality constraints, you lose all the benefits from sequential screening. What the optimal contract will be like is it's no longer really conditioned on I, it's trivial, the contract, and what actually the principal offers is the optimal one given his average belief about the agent. So it's as if the principal said, okay, just wait until you get all the private information and then we write a contract. Okay? So what does that mean for our application? Well, yes. So withdrawal rights indeed safeguard the consumer's informational position. He will buy with the same, he will buy and contract basically under the same conditions as going to a traditional shop. It is as if the contract is offered after observing your theta only. And we could also say, go a little bit beyond that, that these withdrawal rights really level the playing field between internet and traditional shops. Okay. So, so that's about the application. So we're here at the workshop on economic theory. So let me now concentrate on the theory. Okay. So now I would like to show you or demonstrate why we get this proposition 2. So 2 benchmarks. So let's start first when to assume when the ex ante type, the I, is actually known, and we have ex post IR. Well then, what we have is a traditional monopoly problem, Baron-Meyerson, where both the principal and the agent know that the theta will be drawn from the I. So what do we know about this? This is a very well-known studied problem. A fixed price is optimal, so that means the principal will offer just a cutoff, a fixed price. This is the price, probably, and depending on I. And the agent just buys if his theta is larger than the price theta I. So that means that the profit of the principal is just with this probability the theta will be larger than theta I, and this is what he gets. So this is the classic trade-off between rents and efficiency. How do we find the optimal price? You get this virtual surplus, and you see where the virtual surplus is 0. So that defines then your critical price, and that's the optimal contract. Okay. So second benchmark. What if the principal does not see I, or when the principal cannot condition the contract on I? That's what we call a static situation, where the screening is not allowed with respect to the ex ante private information. Well, then we also have a rather standard problem, because what the principal then does is he just considers the average distribution. You calculate the hazard rate of the average distribution, and now you have the same monopoly problem again, but now with respect to the average distribution. So there will be a cutoff again, and the cutoff is now this average, followed from the average virtual surplus. And this is also, of course, what you get when the consumer gets all this information up front. What happens in the traditional store. Okay. So 2 benchmarks. So let me first give you an intuition for our result, why we get this result. And we'll do it with 2 ex ante types, and restricting attention to a menu of option contracts. So what is an option contract here? An option contract is that what the principal offers the agent is a contract consisting of an upfront fee, and then after learning his information theta, he can then exercise his option to keep the good, to really buy the good for the exercise price theta hat. So the idea is, if the agent picks this option contract, he pays F, he then sees theta, and then he says, well, is it now worthwhile for me to actually exercise my option, pay theta hat or not? So that's the idea of a standard option. So what? Okay, so I have to stand a little bit more closer here. So with only an ex ante participation constraint, so this is the standard Courtier-Lee framework, we can have actually that the upfront payments can be negative. So this is going to be important, and that will be the big comparison to a situation where we have an ex post participation constraint, because then we cannot have negative upfront fees, because if you then send the good back, you end up with negative utility, and it is not possible. Okay, so let us suppose, let us see whether the principal really, when using these type of contracts, would like to keep on screening on the ex ante private information on the I. So suppose it's offering, the principal is actually offering 2 option contracts, one for type 1, one for type 2. It's incentive compatible, and we are really having here sequential screening. These 2 option contracts are different. So our claim is then, of course, that under an ex post participation constraint, sequential screening contracts are feasible but not optimal. This is not optimal. We can improve on that. So let me show you an argument. It's, for in the case of these types of contract, is very simple. So the gammas the option contracts are different. So that means that these cutoffs are different. So suppose that J is the one with the higher one. Now, because of incentive compatibility means, J takes his contract, so the contract for J gives him at least as much utility as contract I. Now already here, there are already 2 reasons why this contract combination cannot be optimal. Why not? There are 2 reasons why the principal can do better than, rather than offering this contract gamma J to type J, he should offer gamma I to type J. Why? Well, type J would generate more surplus under the gamma I contract, because the price is lower, so he will exercise his option more often. On the other hand, gamma I requires less rents to J. That's directly from this incentive constraint. He takes J because it gives him more rent. So I gives him at most the same rents. So that makes it very clear that if this contract cannot be optimal, it would improve the principal situation to just offer contract I to J. Okay, so I hope this sounds convincing after the lunch. I can't make it simpler than this. I can make it harder, and I will make it harder, but I can't make it simpler. So now you may wonder, but what about sequential screening? What about Courtier-Lee? Why does this not work with Courtier-Lee? Well, the problem is, or the idea is, if we don't have an IR constraint, an ex post IR constraint, then the contract that you're actually offering, this contract gamma I, may actually violate the individual rationality constraint of J. So we have this. So offering this contract to J would be a nice idea, but it would be below his participation. Okay. In contrast, I told you that if you have an ex post participation constraint, the upfront fee is always non-positive. You cannot ask for a real fee. So any contract that you can offer is always gives you always more than 0. So here we have the argument that you can actually give this I contract to J. Okay. So what have we shown? Well, this previous argument shows that static contracts are optimal among option contracts. What is so special about option contracts? Well, option contracts are basically deterministic contracts. So if we would have restricted ourselves that the X lies only between 0 and 1, either you sell it with probability 1 or with probability 0, then the representation with option contracts is identical to a general contract with a general deterministic contract. So basically what we have shown with our argument on the previous slide is that optimal deterministic contracts will not allow for sequential screening. So Humberto is probably then not happy. Humberto would like to see, well, what if there is stochastic? He's nodding already. So, okay, so the task is, and the real economic theory comes now, because this is kindergarten. is to show that, to find conditions, yeah, and I showed you the condition, to show that under our assumptions, yeah, these stochastic contracts are non-optimal. Yeah. Okay, so we have to take care of possibly stochastic contracts. How do we do that? Well, we solve this in 2 steps. So the first step is standard. Yeah, this is just rewriting the problem to get this virtual surplus formulation. Yeah, eliminating out the transfers. Yeah. And then, yeah, we get a problem with formulated in the virtual surplus, yeah, and then we have to find out, yeah, about what are the right incentive constraints, or identify the right incentive constraints under which we can solve our problem. Yeah, we have many incentive constraints, yeah, but we have to find out the right one. Yeah. And here, yeah, I think we realize, yeah, the conceptual contribution of the paper, because, yeah, the usual approach will not work. Okay. So, yeah, here I done the kindergarten step, yeah, rewriting things with this virtual surplus. So you should just believe me that I did this correctly. Yeah, so here you see that it's no longer the formulation with the transfers. Yeah, here's simply the virtual surplus formulation that we always get. Yeah, and this is now what the principal has to maximize, given a monotonicity that xi is non-decreasing. Now this x post in the individual rationality constraint, and we still have the ex ante incentive constraint concerning the ex ante type. Yeah, so this is the problem we have to solve, and I have to argue now that from this problem we get a deterministic contract. Yeah, and then my previous argument showed you already that sequential screening is not optimal, even though it's feasible. It's not. Okay, so why is this so much work? Yeah, why is this? Why did it take us so much time? So with 2 types, it's very simple. Yeah, yeah. Even took some time with 2 types, but 3 types, yeah, really, yeah, was not so nice. So what is the problem? Yeah. Okay, so let me illustrate what goes wrong by using a standard Merle's approach or the Meyerson approach when solving this problem. Yeah. So, recall one of the benchmarks I showed you that I defined the theta I as the monopoly price when type I is common knowledge, where there's no private information at I type. That's the theta I defined by this virtual surplus cutoff. Yeah. So now just order the types, yeah, redefine the types, yeah, as follows, that type 3 had a smaller cutoff, monopoly cutoff than type 2 and type 1. Yeah, this is just a definition, redefinition, relabeling, doesn't mean anything. Yeah? But this shows you a little bit what the incentive constraints are. Yeah? So theta 3 has the lowest cutoff price. So actually, yeah, I really would like to have the theta 3 price rather than the theta 1. Yeah? So incentive compatibility will be, yeah, theta 2 would like to present to be type 3 and y1 to be type 2. Yeah? Okay, so this sounds very, very standard. Yeah, and one way of solving this is, okay, we have all these incentive constraints, but with 3 types, not that many, but still quite a few. Yeah, which one do I take? Well, normally I take just the local ones. Yeah? Yeah. So, yeah, normally you just ignore the monotonicity constraint, you take the local incentive constraint, you start calculating, you get something out of it, and you have to ensure that it's really monotone, and you find conditions under which it is, and then you're fine. Yeah? So why will this not work? Yeah? So suppose we do that. Yeah? So these are the neighboring constraints. Yeah? 1 would like to be 2, 2 like to be 3, so those are the neighbors. Yeah? And keep things simple, start with that, that these utilities of the 0 type is 0. Don't think about that. Yeah? Okay? So one approach is to solve the problem on the previous slide, only with these incentive constraints. Yeah? Solve this relaxed problem, yeah, then hope that xi is non-decreasing and then all remaining IC's constraints are met. Then that would be then okay. Okay, let's do that. So here's your problem. Here's our problem with only these IC constraints. Yeah. So let's just take the Lagrangian, yeah, the objective minus the constraints. Yeah. Because these are positive, has to be positive. Those the Tucker conditions are that they must be non-positive. And consider now, yeah, the derivative of this constraint with respect to type 2, yeah, psi 2 theta. Yeah, so here I have just take the derivative of it. Yeah. So, yeah, if this thing, if this beast here is increasing, it's monotone, then we actually have that we get a deterministic cutoff for type 2, and we are basically fine with type 2. So let's see. So this part is, yes, it's increasing in theta because of the decreasing hazard rate. H2 is decreasing hazard rate. That's good. So what about this part here? So this part is increasing because of the decreasing cross hazard rate. Note that the Lagrange multipliers are negative, so when this is decreasing, this whole thing is increasing. So that's good. And now see where we have a problem. This part here messes everything up. My hazard rate is increasing, my hazard rate was decreasing. I needed that to get here the red part in the right direction, but that messes up the green part. So the one is going up, the other one's going down. I don't know. So it's unclear what's going on. And what's the problem? What's the problem is there's a plus and there's a minus. And this change of signs is actually what messes up my approach. But this plus and minus I get if I take the neighboring incentive constraints. So let's take other incentive constraints. Let's take rather than 1, 2, we take 1, 3, and we keep 2, 3. Now, if we solve the problem with this one, we do get monotonicity. Why? Because we don't have this problem with the plus and the minus. Now, this looks good, but we have a solution only if I'm actually sure that incentive constraint 1, 3 and 2, 3 will really bind. So this would be the right incentive constraint in some sense, if I'm sure that these are the really ones who are binding my problem. So I have to find out if this monotonicity I have is actually okay, that these were really the constraints that are binding me. So what do I mean with a binding constraint? I mean if I throw it out, then I get a solution that would violate this constraint. Okay? Concavity is all nice. So I'm going to solve this problem again, but now I'm going to throw out IC23 and see whether IC23 is really binding. Now if I solve this problem, what do I get? I get that theta 2 hat is a cutoff at theta 2. Yes. And this is the monopoly solution if the principal knew it was type 2. Sorry, this should be a 2. And what I have is basically bunching between type 1 and type 3. Then the principal will offer a monopoly cutoff. That's the monopoly cutoff if he did not know that it was 1 or 3. So where he would know it's not 2, but he's not sure about 1 and 3. Then he takes the average distribution of 1 and 3, and you can calculate this cutoff. Now everything is, this would really violate IC23 when this cutoff we get, these two cutoffs, are ordered in such a way that theta 2 is larger than theta 1 out of 3 bar. Because then type 2 would really like to pretend to be the 1, 3 type, and this solution here violates IC23. Well, this happens when theta 2 is larger than this average theta bar. So only if theta 2 is larger than the average theta bar, then I have now shown that indeed the optimal contract is deterministic, and I have what I've got, and the sequential screening is not optimal. Everything is like I promised it to be. So when whether theta 2 is actually larger than theta bar, depends of course on the primitives, on the PIs and the GIs. It can be, but it could also be the other way around. And then I have a problem again. What kind of solution do we then have? Well then, what happens to work is, if I take other sets of incentive constraints, I should not have thrown out 1, 2, I should have thrown out IC23 and replace it by IC13. Now I can do the whole, song and dance. And this is from David, again, and I get actually that, I get against monotonicity, everything is fine, under the condition that this incentive constraint is then really binding, and it's actually, binding, actually in the case I'm now in, so, and this, so depending on the distributions, yeah, I have to take different incentive constraints. Okay. So now your question is, of course, well, yeah, so with 3 types it works. Yeah. What about 4 types? What about 5 types? What about 6 types? Yeah. What about n types? Yeah. That was, yeah, after showing this with 3 types, it took us half a year until a year. Yeah. We did 4 types, which took us 3/4 of a year. Yeah. And we even did 5 types, and it always worked. Yeah. So, yeah, the whole problem is, how many minutes do I have? 8 minutes. Okay, that should be more or less okay. Yeah. Okay, so yeah, in general, yeah, we would like to have this for n types, not 2, not 3, not 4, not 5. Yeah. Okay, sorry. No, that's fine. Fine. So that was the aspirin. Okay, so what is the general problem? Yeah, we have to find a set of incentive constraints, yeah, so that all types, yeah, all ex-ante types, yeah, when we then have this, yeah, relaxed problem, we solve this relaxed problem, we have the monotonicity satisfied, and at the same time, we really know that we took the right incentive constraints in the sense that they're really binding. Okay. So yeah, after 3 types, 4 types, 5 types, yeah, we finally got a very lengthy constructive procedure to identify the ICs. Yeah, we actually wrote down the proof. It took 40 pages because it's by induction and 3 or 4 times induction. Yeah. So yeah, so we thought a little bit more. Yeah, and we now have a much shorter indirect procedure to identify the ICs. Yeah, so you may have heard a different version where we have this procedure. It looks very impressive, but I'm sorry, we now do it differently. Okay, so what do? Yeah, we have to identify the subset of IC constraints, find the subset C of those pairs of IC constraints. What we do then is, yeah, we then consider the relaxed problem. We only take the incentive constraints from this constraint set. Yeah. We then build this virtual Lagrangian, like I did with 3 types. Yeah, and notice again, yeah, there are in general minuses and pluses. Yeah, so I should take the right ones, right C's, so that I don't end up with minuses and pluses. Yeah, overall. Yeah. Then if I do that, yeah, then the static solution solves this problem. Yeah, if I find my multipliers, yeah, so that I have monotonicity. Yeah. And I have a cutoff. Yeah, the cutoff is this static cutoff. Yeah, and I have the multipliers with the right signs. Yeah, non-positive. Okay, so how do we do that? So yeah, the 3 type case gives you some information what to do. Yeah? So we call a set C directed. Yeah, if ij, so incentive constraint ij is in C, it means that there's no other incentive constraint in J, so that ki is in J. Yeah, so if ai is I likes to be J, yeah, then there's no k who likes to be I. Yeah, that's a little bit the idea. Yeah. And the trick with this directed is that we actually end up with this virtual formulation, this big psi, yeah, with either only minuses or only pluses. Yeah. Okay. And then, yeah, we have the monotonicity in the psi. Yeah. And yeah, like I told you, these Morley's constraints, just the neighboring constraints, are actually the wrong ones. Yeah. Because then we always have pluses and minuses, and that screws things up. So, yeah, what is now the recipe to find the C star? Yeah. Yeah. So you saw that, yeah, what was important in the 3 type example is whether this monopoly cutoff for type I is larger or smaller than the average theta bar. Yeah? And that's the key, yeah, inside to construct your C star set. Yeah? So what we're going to do is we're going to put only ij's in C star, yeah, with theta i's when theta I is smaller than theta bar, and j when the theta j is larger than theta bar. Yeah? Those are the C's that are going to matter. Yeah? Only those we will put in our relaxed program, and only those, for those we will then maximize. Yeah? And then, yes, so by construction the C star is directed, so we don't have the minus plus problem. Yeah, and then the indirect procedure is to use Farkas lemma to show that actually you find these non-positive multipliers, so that at theta bar you have this cutoff. Yeah? Okay, so let me come. That's now the proof. It takes more than one page, but substantially less than 40. But that's how things work. So let me just conclude. So what do? We introduce ex post participation constraint in the standard sequential screening model. And we then show that static contracts are optimal. You don't want to screen sequentially, even though you can. So it's not an infeasibility result. The principle could do it, but it's simply too costly. What about how robust is the result? You might wonder, or you might be. What about I took the participation constraint, the ex ante and the ex post participation constraint is both 0. What if there's a difference? When it's the ex post participation constraint, you can have some negativity there, but not 0. According to the EU regulation, when you send back your good to withdraw, you actually have to pay the postage. So you lose a little bit of money. So the ex post outside option can be smaller than the ex ante outside option. There's a bound, of course. But it's bounded away. This lower bound, and we still have our result. Of course, if this bound is very so if the outside option is much smaller than the ex ante outside option, we go back to Corti-Lee framework. Okay. So just back to the application. So we confirm that in the context of the EU regulation, withdrawal rights restore this informational position of the consumer. That seemed to have been the main issue from the perspective of the EU. So this EU regulation withdrawal right goes back to 90s. And there were no Amazon yet, so we did not have real browsers. So if you read what they were thinking about, they were selling goods over Minitel. I don't know the French people here whether they still know Minitel. Where you really there were no pictures. It was just text, and you could order something. So the information. Now you see all the nice information and with pictures and everything. But at the time, informational position was really bad if you bought something over Minitel. And moreover, the withdrawal rights, really levels the playing field between the internet and the traditional shops. So that's not originally the idea of the EU regulators. But there's no average, no artificial advantage of internet stores now over the traditional stores for selling goods. You may be worried that there's an artificial anti-competitive effect of internet shops versus traditional shops. And I'll leave it there.
And now Xavier is going to discuss the paper.
Actually, I was planning to do this presentation before Roland, so I will have to change a little bit. So this paper deals with withdrawal rights. Roland introduced the withdrawal rights in sales contracts. They work just like a kind of a cooling off period. You buy the good, and then if you realize that the good is not what you wanted, and then you can return the good to the seller. So actually, it's mostly important for when we consider